Okay, so this is the third podcast on atomic theory. It is the most straightforward one of them all. Um, so what I want to talk about is go a little bit deeper into um, this idea of atomic mass units. So if you measure the mass of a heavy atom, so um, xenon or iron, something that's more towards the middle of the periodic table, and you measure it, and let's say it has a mass of 4 times 10 to the negative 22 grams. That is actually a very, very heavy atom. So scientists don't want to memorize all these masses. Imagine if you had all these weird numbers on the periodic table: 10 to the negative 10, 22, 3.2 times 10 to the negative 21. It could, it's going to be a very, very, very more complicated periodic table. So what they did is they said, okay, let's take this number, 1.66 times 10 to the negative 24 grams, which I believe is the mass of a carbon atom. And what they said is, let's make it equal to one atomic mass unit. Let's just call it an atomic mass unit. So when they did the conversions, um, one proton had 1.0073 atomic mass units. One neutron had a 1.0087 atomic mass unit, and one electron had this atomic mass unit, which is really tiny because of the negative 4. So what do you notice about the subatomic particles? We notice that the protons and the neutrons have the same, um, we say in science, we say that they have the same atomic mass. Okay, they have the same mass, but if you look at it from the perspective of 5 sig figs, the neutron's bigger, it's larger in mass, but we're gonna say that they're the same mass. Okay, even though the neutron's heavier and the electron is small. So when we consider the mass of the atom, we just consider the protons and the neutrons. We ignore the mass of the electrons. We say that the mass of the electron is negligible. Now, this is a little piece of the periodic table. This is the center of it is going to show you the symbol, which is sodium. Um, and then on top, it's going to show you the atomic number. The atomic number is the smaller number, and it tells you the number of protons. And at the very bottom, it tells you the mass, the atomic mass of that atom. So it is actually the atomic mass unit of that atom. And you may ask, why is it not 23? Why is it 22.98? And the reason why is because this is an average of all of the sodium isotopes that exist in abundance on Earth. So you take all of these sodium isotopes, you average out the atomic mass unit, and you come up with 22.98. And that tells us that most of the sodium isotopes are actually sodium 23s because it's closer to 22.98 is closer to 23. Now, the reason why I put this is because sometimes you might see it differently. Um, and um, the thing to remember is that the smaller number is the proton number, the smaller number is the atomic number. So sodium 11, 23. Usually when we name these, we name them based on their mass. So sodium 23. Know that the 23 is the mass number, 11 is the atomic number. This is the atomic mass number. I'm sorry, this is the atomic number, which is the proton number. This is the mass number, which is the atomic weight. Okay, so the smaller number is the proton number, and you might also see it like this. So sodium 23, it just means, oh, it's sodium with 23 mass units, meaning that when you add the number of protons and neutrons, you get 23. How many protons one atom have? Whatever this number is, if it's 11, that's how many protons it has. It will never change. Um, as long if you for some reason end up changing the number of protons, then we no longer call it that atom. We call it a different atom. So, um, for example, nitrogen has an atomic number of 7, that means it has 7 protons. But if we change it to 8, then it's no longer called nitrogen. It's now called oxygen, because oxygen has 8 protons. So the atomic number tells you the identity of the element. How about electrons? How many electrons will you have? Um, the number of electrons is equal to the number of protons if the atom is neutral, meaning that it doesn't have any charge. So let's look at that. A lithium, for example, let's look here. Lithium here, just look at this. Lithium has 3 electrons, and that is considered neutral. Okay, but okay, let me step back. If you have 3 protons in the nucleus, which we have 3 of if you look at the color, and you have 3 electrons, that means that the atom is neutral because they're equivalent, right? So if lithium has 3 protons, that means it should have 3 electrons if it's neutral, okay? But atoms don't work that way all the time. They're not always neutral, and they want to become stable. So in order to become stable, they end up giving up electrons, they end up accepting electrons, or they end up sharing them. In this case, lithium is losing an electron, and if it loses an electron, then it becomes positive. So it goes from Li neutral with 3 electrons to Li positive when it loses an electron. So if an atom loses an electron, it becomes positively charged. For example, sodium typically gains an electron. So, I'm sorry, sodium typically loses an electron. So it's going to be positive 1 if it just loses 1. Chlorine here likes to accept electrons, so it's going to be negative. Okay, think of opposites. If an atom gains, it's going to be negatively charged. If an atom loses electrons, it's going to be positively charged. If it's plus 2, it means it loses 2. If it's negative 4, then it means it gains 4. So make sure you know the rules, okay? You no longer call these ions, I'm sorry, atoms, you now call them ions. Okay, so again, you no longer call them atoms if they have a charge, you call them ions. And there are 2 different types. Cations, which are positive. Cats have paws, that's the way I remember it. Cations have paws, meaning that they're positive. Paws positive. Anions are negative. Um, so how do you find the number of neutrons and protons? It's very easy actually. Um, for example, carbon. If you look at carbon on the periodic table, it has an atomic number of 6. So um you're gonna write 6. P has 6 protons because it has an atomic number of 6. The electrons, assuming carbon's neutral, it's also going to be 6. How do you find the number of neutrons? Well, this is a little different. What you have to do is you have to take the whole mass. We know that carbon has 12 atomic mass units. So if we remove the protons, we know how many neutrons we have. So if you subtract the total mass by 6, because we're getting rid of the protons and we want to know how many neutrons we have, that will tell us how many neutrons we have. So 6, 6, and 6. Okay, let's try another one. See if you could do this one. Think about this one and then try this one. Okay, so pause it and then come back to it. Okay, beryllium. So beryllium on the periodic table. So I actually don't know the number, so I'm going to go to the periodic table and I am going to find it. So periodic table, you're gonna look for what are we looking for? Beryllium. So beryllium is it's a metal. So if you look here, I know it's kind of hard to see. It has an atomic number of 4 and a mass of 9. So number 4 is the smaller number, so it's the proton number. So it's 4. If beryllium's neutral, it's equal to the number of protons. And the neutrons would just be the mass, the total mass, which we found to be 9 on the periodic table. Subtract that from the number of protons, and that will give us the um, the number of neutrons, which is 445. Okay, so go ahead and do these ones. Um, find a number of protons, electrons, and neutrons without looking at the answers. Okay, so go ahead and pause it here, and then check your answers down here. Okay, see if you got the right answers. Okay, so that's the end of our summer homework. I hope that wasn't too confusing. If it was, I really recommend that you guys form study groups. Ask me, send me a few emails. I'll try my best to have a small review session, but, honestly, I'm a little busy during the summer. So I hope you could figure it out on your own. And if you don't, then, we're going to review the first day. Ask me a bunch of questions, highlight stuff, put all your questions on another sheet of paper, and I'll try to answer them on the first day of class. The second day of class, we're going to have our test. So please, 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 please do your summer homework and review it as well. So you're going to have a problem set that hopefully will help you understand all these concepts. All right, thank you.